Hello, good evening, friends. And today we are going to study on the topic of Wheatstone Bridge. So, we all know that this Wheatstone Bridge consists of four registers like this, and we are also calling it as the four arms of Wheatstone Bridge. And there is one more registers connected in between these two registers. So that is a galvanometer register. So this is a battery supply to this Wheatstone bridge. So these are the four registers. We can call it as a P, Q, R and S. And here what is the speciality of this bridge is to find out a current flowing through this circuit. So the current flowing through this circuit, there is a bit difficulty here. This is difficulty is because these registers are not connected in a series, this P and G, and even P and Q also they are not connected in a series. The similarly R and G and R and S, and even these registers are also not connected like a parallelly, so they are not connected in a parallel form. See, this P and R, one end of the P and one end of the R is connected, but on the other end the P is connected to G and R is connected to G. So the same thing is happening in a Q and S. So we cannot find a effective resistance here because the resistance are not connected parallelly, or they are not connected as a series. So then how to find out they are not connected? Then how to find out a effective current flowing through this circuit? So even applying a Kirchhoff's law, Kirchhoff's voltage or a current law, that is also a bit difficulty. So to understand the current flowing through this circuit, what we can make is, see, this diagram I can draw like this. This is one resistor P and another resistor Q, and this is a R resistor and this is the S resistor. So now I have connected a battery to all these circuits. So now I can easily calculate a current flowing through this circuit. Because this P of one end is connected to the another end of the resistor, that is Q, and the one end of the R is connected to another end of the resistor S. So P and Q are making a series and R and S are also making a series, and this P and Q make a effective resistance that I am calling it as a RS, and R and S they are making a effective resistance that I am calling it as a P. So this is a battery supply. So now both are connected in a parallel. So with the help of this I can calculate, see, this RP I can mention it as a RS dash, so this RS dash. So RS as well as the RS dash are connected in a parallel. So with the help of parallel combination we can easily find out a effective resistance RP. So then I can call it as a, then I can easily calculate a current flowing through this circuit. So how to achieve this? So how to make this galvanometer resistance a value 0, means the current flowing through this galvanometer must be 0, then only we can easily calculate a current flowing through this circuit. So now the question comes, how to make a current flowing through this galvanometer 0. So this is the main idea behind this Wheatstone bridge. So how to make a resistance, or how to make a current flowing through the galvanometer 0. So to make this, let us take an example here. So I want in this point Iz equal to 0. So this is possible only when the potential drop at this point, that I am calling it as a Va, and the potential drop at this point we are calling it as a Vb. So that must be equal. See, current flows only when there is a potential difference between the 2 points. So now the potential difference Va and Vb both are equal, then current will become 0. So once the current becomes 0, then I can use this circuit. So I can easily find out the current flowing through this circuit. So now the question comes, how to make this potential difference Va is equal to Vb. So this point, whatever the potential value, and this point potential value must be 0. So we all know that the temperature flows from higher level to lower level, and pressure flows from higher level to lower level. So similarly, potential also flows from higher level to lower level. But in this case, what is happening? The potential value in the both the cases are same. Suppose if there is a Va is 10 volt and Vb is 10 volt, now because of this we will get a 0 current. So suppose if there is 10 volt at a Va and 12 volt at a Va and 10 volt at a B, then what will happen? There may be a current between those 2 points. So now how to make a Va is equal to Vb? So to achieve this, what we do is we just make a balance of this circuit. So how to balance this Wheatstone bridge circuit? So now to balance that, what I will do is I will take a 10 ohm resistor at a P point and 40 ohm resistor at a Q point. Similarly 20 ohm I take it as a resistor at R point, then I take 80 ohm at a S resistor. So now what will happen is, so this is a G, so we need to make a Iz equal to 0. So to achieve this, what I have taken is a P is 10 ohm and Q is 40 ohm and R is 20 ohm and S is 80 ohm. So see here, comparing these two resistors and comparing these two resistors, they are proportional to each other. See, if I take a ratio of this P by Q, then what I will get? 10 by 40 is equal to 1 by 4. So similarly, if I take a ratio of R by S, 20 by 80 is equal to 1 by 4. So suppose if I take even P by R, so that P by R is 10 by 20, so the ratio is 1 by 2. And similarly, I can take a Q by S, so 40 by 80, then also I will get a 1 by 2. So the resistors are proportional to each other. So when these resistors are proportional to each other, then what will happen to this potential drop between these 2 points? So the potential drop between P and Q will be the same at a potential drop between the R and S. Do you agree? So if the potential drop across the P and Q is in the ratio of x raised to 2x, so now the potential drop across R and S also becomes x raised to 2x. So due to this, the potential drop across this resistor P point and the potential drop across the point R resistor. So now what will happen? The potential drop at a VA must be equal to potential drop at point VB. So the potential drop at VA is equal to potential drop at a VB. Now we can easily calculate a current flowing through this circuit. So this is, now it becomes a very simple. So P, Q, R and S. Now we can easily calculate a current flowing through this circuit with the help of series combination of a resistor as well as a parallel combination of the resistor. So here one more thing is, this Wheatstone bridge, even if I don't know the value of Q, I know only the value of P as a 10 ohm resistor and R is 20 ohm resistor and S is 80 ohm resistor. Then how to find out a Q value? So the Q value becomes, so with the help of this, if it is a Wheatstone bridge, then we take a proportional like this, P by Q is equal to R by S. So we know the P value is 10, P value is 10 and Q value I don't know, and R value is 20 and S value is 80 ohm. So 10 into 80 divided by 20, so this will give the value of resistor Q. So this will come, Q is equal to 40. So with the help of Wheatstone bridge, we can find out the unknown value of the resistor. So the main application is this Wheatstone bridge we can use to measure the temperature. So with respect to changes in the value of resistance, we can measure the temperature. So this is a very high sensitive device, so we are using it as to measure the temperature of water or temperature of any liquid material. So I hope you have all understand the working principle behind this Wheatstone bridge and its importance. And in the next class we are going to solve some numericals on this Wheatstone bridge. And thank you.